Write the balanced reaction for the complete combustion of butane, C4H10. Butane is an example of what we call a hydrocarbon. Hydrocarbons are compounds composed of only two elements, hydrogen and carbon. So the name is hydrocarbon. The problem says that the hydrocarbon undergoes combustion. So what do we mean by combustion? Combustion is a reaction with oxygen gas. So the other reactant is oxygen gas. And the problem says that the combustion is complete. When you say complete combustion of a hydrocarbon, there are only two products, carbon dioxide and water. So any hydrocarbon that undergoes complete combustion forms carbon dioxide and water. So let's write the chemical formula for our hydrocarbon butane, C4H10. Oxygen gas is O2, carbon dioxide is CO2, and water is H2O. We only need to balance three elements on both the left and the right sides of the equation. And these are carbon, hydrogen, and oxygen. I will give you a tip. Start first with carbon, then hydrogen, and lastly balance oxygen. So let's count the number of carbons on the left side. We have 4. And on the right side, we have 1. So how do we balance carbon? We put the coefficient 4 on carbon dioxide. So that 4 times 1, that's equal to 4. So carbon is already balanced. Let's move on to hydrogen. We have 10 hydrogens on the left side, and on the right side, we have 2. So in order to balance hydrogen, we need to put the coefficient 5 on water, because 5 times 2, that's equal to 10. So hydrogen is already balanced. Lastly, we count oxygen. So on the left side, we have 2 oxygens, and on the right side, we have 4 times 2, that's 8, plus 5 times 1, that's 5. So 8 plus 5, that's equal to 13. So how do we balance oxygen? We put the coefficient 13 halves or 13 over 2 on O2. So that 13 over 2 times 2, that's equal to 13. So oxygen is already balanced. However, most professors do not want fractions as coefficients in balanced equation. They prefer whole numbers. So how do we get rid of the fraction? What you need to do is to multiply the entire equation by 2. So let's start with C4H10. 2 times 1, which is the coefficient of C4H10, that's equal to 2. So 2 C4H10 plus 2 times 13 over 2, that's 13 O2. 2 times 4, that's 8 CO2. And 2 times 5, that's 10 H2O. Now let's check if this is really balanced. Let's quickly count the number of CHO on both the left and right sides. So on the left side, we have 2 times 4, that's 8 carbons. On the right side, we have 8 times 1, that's 8 carbons. So carbon is already balanced. Next is hydrogen. On the left side, we have 2 times 10, that's 20 hydrogens. And on the right side, we have 10 times 2, that's also 20 hydrogens. So hydrogen is already balanced. And finally, for oxygen, on the left side, we have 13 times 2, that's 26 hydrogens. And on the right side, we have 8 times 2, that's 16, plus we have 10 times 1, that's 10. 16 plus 10 is equal to 26. So oxygen is already balanced. Therefore, the answer to this question is this one. 2C4H10 plus 13O2. Products are 8CO2 and 10H2O.